when we look at when we put together all our knowledge of trigonometric functions, we know we can graph them, Nick. Just watch for now, yeah. We know we can graph them. We know we can differentiate them. We know we can integrate them. Now we're gonna put them all together because when we look at the questions, they're not going to be so neatly structured in a sense where okay, now I know I'm differentiating, now I know I'm integrating, right? They're going to give you a mix of these questions, and you have to be familiar immediately with what to do. And first things first, when I look at this, I'm seeing I've got actually two functions multiplied together. What are my two functions?
Sine and cos.
Yeah, sine and cos. So you have to realize, if you have two functions multiplied together, what am I going to need to use?
Product
Rule, right? And product rule says that if I have y equals to u times v, then the derivative can be written as vu dash plus uv dash. And you have to be aware of that, right? You have to be aware that if you have two functions multiplied together, the first thing you think of is product rule. And again, I always lay it out in the same way. I always write what my u's and v's are. What is my u? It's the first function, which is sine of x. What's my v? It's just cos of x, right? I'm just looking at the same function. Yeah. And I always lay it out like this. When Mark is running out of ink, I always lay it out like this because it's really easy once you have those values to just put them together, right? U dash is just going to be cos of x, and v dash. Just want to be careful. What's the derivative of cos of x?
Negative sine.
Good. Okay. Okay. That way, you're making sure you're not making any mistakes there. And then all you do is just put them together in this part here. You've got vu dash. Well, that's cos of x times cos of x. That's just cos squared of x.
So you did the line with your v's. Oh, no, you did it.
I did do them.
That's good.
And then I'm going to add here. What am I going to add? I'm going to add uv dash. Now, just be careful. There's going to be a negative here. What's sine of x times negative sine of x?
Negative sine of x squared.
Negative sine squared x, right? And because I've written like this, I won't get any operations wrong. That would just be cos squared of x minus sine squared of x.
Yes.
Because you're adding that negative. Alright. Any questions about that?
No.
Not too bad, right? I think the hard part is just recognizing that you have to do that, right? Recognizing that you have to use the product rule in this case. And this one's no different. What rule do I have to use here? Yeah, right, I'm like, quotient rule, right? So I know that quotient rule says that if I have u over v, then my derivative is equal to, and this is why I write it as vu dash plus uv dash. It's because I'll get the same form on the numerator. It's vu dash plus uv dash
On v squared.
over v squared, right? So it's very similar. All you have to memorize is that top component, and it works for both of them.
Isn't it minus on top or is it plus?
Oh, it's a minus.
Is it minus? Sorry, yeah, you're right.
Yeah, it is on.
Yeah. Oh man, I'm getting rusty. vu dash minus uv dash. That's right. Sorry. Let's keep going, right?
Yes.
Again, I just write out my u's and v's. I've got u is equal to sine of x, and v is equal to x, and then I just take those derivatives. Like, same thing here. Cos of x, and this one's easy. What's v dash? Yeah, it's just 1, right? As Nathan said. And then it makes it really easy to put them together. That's just going to be equal to vu dash. Well, that's x times cos of x. Minus, what's uv dash? That's just,
Sine x times what?
which is just,
Sine of x.
yeah. All over v squared, which is just going to be x squared. Yeah. Okay. Any questions on that? Did you guys get that one?
Could you simplify the x cos x?
This one here?
Just leave it like that, yeah.
Well, how would you simplify it? What are you thinking?
I don't know.
Of cos
I
x.
think it's wrong.
You want to take like the x out or
Cos
something?
x squared plus.
Ah, that's a really interesting question, right? And it sort of relates to like this. You're saying could that be written as cos squared of x like that? Is that what you're asking? So the reason why you can't do that is it's a good question, right? It's because this 2 cos of x is not the same as cos of 2x, right? Because when you have something on the outside, what does that affect again? It affects the amplitude of the graph, right? And when you're looking at this one, this is actually inside the function, right? You can't kind of interchangeably swap them. Okay, they're actually separate kind of operations. It's a good question though. And again, we have to be really familiar with these different forms here. When I have something like this, okay, if I was to expand this out, I'd have 8 of these brackets because it's sine of x minus 1 all to the power 8.
I reckon you could do it
Maybe you could. It would probably take you a very, very long time.
But which way did you want to do it, sir?
Right?
Which way did you want to do it?
Well, as in, think about what this actually means, right? It means I have sine of x minus 1, and I have it multiplied by itself 8 times. That's what to the power of 8 means. And I can use chain rule. What does chain rule say again? Yep, so I want to, chain rule states that if I have some function to some power, what I can do is I can drop that power down, but what do I have to do with the inside function?
You find the derivative.
I have to find the derivative. So first thing I always do, I drop the power down. What's the derivative of the inside function?
Cos x.
Yeah, what about this 1 though? That's just going to be 0, right? It's just a constant. Don't be phased by
But
that.
you leave it like that and you use the chain rule and then times it out the front.
In the original function I do, yeah? But when I take the derivative,
But you're not supposed to take the derivative of the middle one, you just times the derivative by the front number. So I don't know.
no, you have to take the derivative of the inside function as well for chain rule. And then what I do, I keep the original function the same. That's sine of x minus 1 all to the power 7, right?
That's
Because
what I was
of the
saying,
difference.
that's what I was trying to say.
Yeah, the inside function stays the same.
Yeah, that's what I was trying to say.
Yeah,
and then
you're
you
right.
times the front by the derivative.
Yeah, that's exactly right. Yeah, you're right. So any questions about that? You have to be able to recognize these forms.
Wait, how do you
right?
get the cos x at the front again?
Because with chain rule, if you have something like this, I'll give you an easy example. 2x plus 1 all to the power 5. You remember, hang on, this means that this is multiplied by itself 5 times. To find the derivative, we have to drop the power down, but then I have to multiply by the derivative of the inside function, which is just
Oh, yeah.
2,
And that one cancelled out up there.
And then you keep the other bit.
and then I decrease the power
Yeah,
by
I
1.
got.
Makes more sense when you.
So same thing with this one, except I just replace it with trigonometric functions.